When the systems we rely on collapse, it happens silently at first, almost imperceptibly. Electrical grids flicker, water pressure drops, trucks stop moving along highways, and suddenly the invisible threads holding modern civilization together vanish. Within hours, the illusion of security shatters, leaving communities exposed, unprepared, and scrambling for resources that no longer have value in the same way they did yesterday. In this environment, the things that matter are not precious metals, luxury goods, or high-tech devices. They are the overlooked cheap items that serve critical survival functions. Items that allow humans to secure water, generate heat, preserve food, maintain hygiene, and repair the environment around them. These seemingly mundane objects transform into tools worth far more than gold, because they become the lifelines between functionality and chaos. The first of these items is the disposable lighter. Under normal circumstances, it is a pocket accessory of negligible cost. Yet, from a thermodynamic and survival engineering perspective, it is one of the most concentrated energy delivery systems ever mass-produced. Fire is not merely warmth. It is a fundamental tool for survival. It purifies water, cooks food, sterilizes tools, creates psychological comfort, and enables metalworking and plastic shaping when infrastructure fails. The common misunderstanding is that fire can always be made through primitive methods. Friction-based techniques, bow drills, fire plows, or flint and steel, require dry materials, precise skill, and often fail under stress or inclement conditions. Disaster research consistently demonstrates that inexperienced individuals cannot reliably generate fire this way in emergencies. A single lighter bypasses all these limitations. It provides hundreds of ignition attempts in a compact, weather-resistant package, transforming the ability to survive almost instantly. In Puerto Rico, after Hurricane Maria, lighters became one of the most traded and valuable items within days of the grid failure, far outstripping expensive electronics or jewelry in practical value. Once the ability to make fire is secured, the next challenge is managing water, a resource far more critical than most realize. This brings us to the second item: inexpensive water purification tablets or drops. Most people misunderstand water purification as a convenience, when in reality it is a fundamental barrier to life. Pathogen contamination, chemical runoff, and bacterial proliferation turn seemingly safe water into a vector of disease within hours. Boiling is effective but requires fire, containers, and fuel, all of which may be scarce. Chemical purification through chlorine, iodine, or stabilizing drops allows individuals to treat water in small portable volumes without relying on infrastructure. The hidden science lies in the principles of microbiology and reaction kinetics. These chemicals disrupt cell membranes and deactivate viruses and bacteria in predictable timeframes, providing a scientifically reliable method of sterilization. Evidence from disaster zones, including earthquake-struck regions of Nepal and Haiti, shows that communities with access to chemical water treatment had markedly lower rates of gastrointestinal disease than those relying solely on improvised filtration or boiling. The survival implication is clear. A small, cheap bottle of chemical treatment can convert an unusable water source into a life-sustaining resource, multiplying human resilience in the first critical days of infrastructure collapse. The escalation becomes immediate. Without water treatment capability, even brief exposure to contaminated water can incapacitate an individual, rendering fire, food, and shelter insufficient for survival. The third indispensable item is the humble role of duct tape. At first glance, it seems a household convenience, a simple tool for minor repairs. Yet in survival contexts, it becomes an engineering multi-purpose solution of extraordinary utility. Structural integrity, temporary shelter, first aid splints, water pipe repair, tool modification. Duct tape allows improvisation in ways that conventional hardware cannot replicate. Misunderstandings occur when people assume nails, screws, or glue are sufficient. These require proper surfaces, tools, and time. Duct tape's hidden scientific advantage is in its viscoelastic adhesive technology, which distributes stress across surfaces and remains functional across a wide temperature range. Emergency management studies and post-disaster housing highlight that even minimal access to duct tape dramatically reduces structural failure in temporary shelters and prevents exposure-related illness. Its survival implications extend beyond immediate repairs. Duct tape enables field engineering, allowing individuals to modify existing objects to create new functions, from waterproofing containers to securing clothing against weather exposure. Next in importance is the seemingly trivial, yet extraordinarily versatile tool, paracord. Often sold as lightweight camping rope, paracord is engineered for tensile strength, abrasion resistance, and modularity. The misunderstanding is that rope is a simple tie. In reality, it is a framework for survival infrastructure. Paracord can be used for shelter construction, trapping, gear repair, fire-making lanyards, improvised harnesses, and even medical slings or tourniquets in emergencies. The hidden engineering science is in its braided nylon core, which balances elasticity and strength while resisting environmental degradation. Empirical evidence from wilderness survival training and disaster response confirms that small lengths of high-quality cordage drastically increase the functional options for shelter, transport, and protection. Survival implications are profound. 1 kilogram of paracord can replace dozens of improvised bindings, stabilizing shelters and securing critical resources in unpredictable environments. The fifth item is aluminum foil, a cheap, lightweight material with unexpectedly critical applications. Misunderstandings abound because it is perceived as a cooking convenience rather than a versatile survival tool. In reality, aluminum foil is a highly conductive, reflective, and malleable material, allowing it to serve as insulation, signal reflector, emergency water catchment liner, and lightweight cooking vessel when shaped appropriately. The hidden material science revolves around its thermal conductivity and ability to reflect radiant heat, which can be used to conserve energy in shelters, cook food evenly over fire, and even signal for rescue through reflection. Historical disaster response case studies demonstrate that communities improvising with aluminum foil for water heating and insulation maintained higher energy efficiency and reduced heat loss, directly correlating with survival rates in colder climates. Escalation is immediate. Without inexpensive reflective and heat-conductive materials, human energy expenditure multiplies, accelerating fatigue, exposure risk, and vulnerability. The sixth essential item is the simple safety pin. Often dismissed as trivial, safety pins embody a high utility density in survival contexts. Misunderstandings are common. Most people underestimate the variety of survival applications. A safety pin can function as a clothing repair tool, medical fastener, fish hook improvised from its shape, small latch, or emergency lock for containers. The hidden principle lies in its mechanical leverage and metal ductility. Even small steel pins can endure stress far beyond their size when applied properly. Evidence emerges from both wilderness survival accounts and post-disaster shelters, where minor clothing or gear failures without pins lead to exposure, injury, or compromised sanitation. Survival implications are clear. A small collection of safety pins enables individuals to maintain clothing, medical equipment, and improvised tools, preserving functionality in ways that high-cost items cannot replicate. Finally, the seventh item is standard 5-gallon plastic buckets with lids. Their importance is overlooked in daily life, yet they become foundational for storage, water transport, waste management, and even improvised seating or cooking stations. Misunderstandings arise when people assume containers are interchangeable. The durability, sealing capability, and volume of these buckets make them particularly effective in survival scenarios. The hidden engineering principle is in their polymer composition and reinforced molding, allowing repeated use under load, resistance to UV degradation, and compatibility with chemical treatments for water storage. Empirical evidence from disaster relief operations demonstrates that communities with a modest number of durable buckets can sustain clean water access, food preservation, and sanitation far longer than communities without proper containers. Survival implications escalate quickly. The difference between exposure to contaminated water or secure storage for perishable items can hinge entirely on having these inexpensive, mass-produced buckets. Taken together, these 7 items, lighters, water treatment chemicals, duct tape, paracord, aluminum foil, safety pins, and 5-gallon buckets form a toolkit whose combined survival value far exceeds conventional wealth. Each item addresses a specific survival bottleneck: ignition, hydration, shelter integrity, structural repair, heat and cooking management, gear maintenance, and storage. The misunderstanding that survival depends on weapons, gold, or electronics blinds individuals to the practical multipliers embedded in these cheap, mass-produced objects. The hidden science underlying each item demonstrates a consistent pattern: functional utility, reliability under stress, compact energy density, and versatility under unpredictable conditions. Disaster evidence confirms that these objects consistently emerge as critical resources in the first days and weeks of societal disruption. The implications are universal. A strategic accumulation of these items, informed by scientific principles rather than speculation, substantially increases the likelihood of survival and functional resilience in any post-collapse environment. As infrastructure failure progresses, the scarcity of these items escalates. Stores quickly run out, hoarding begins, and the small cost of acquisition today becomes irrelevant when supply chains no longer exist. Individuals who understand utility density and logistical leverage will maintain critical capabilities, while others struggle with tasks previously taken for granted. Boiling water, constructing shelters, repairing clothing, or transporting resources. In essence, the modern post-collapse economy reorders value according to immediate, functional utility rather than abstract wealth, and those who have recognized these 7 cheap items as keystone survival tools gain a disproportionate advantage in maintaining life, health, and autonomy. The cycle of danger, analysis, misunderstanding, hidden science, evidence, survival implication, escalation, and transition repeats continuously in every disaster scenario, yet most individuals fail to anticipate it. Fire without water is insufficient. Water without containers is precarious. Shelter without repair tools is temporary. Each cheap item amplifies the effectiveness of the others, creating an integrated survival system built from objects costing less than $1 apiece, yet collectively worth far more than gold when modern systems fail. In a world stripped of electricity, logistics, and mass production, the true currency becomes functionality, reliability, and the scientific exploitation of everyday materials that most people ignore until it is too late.